All right, folks, welcome back to our analytics. This is a series that I have, as you might know, that I have created for teaching and my learning myself R. It's a beautiful language. Till now, I have been able to study a lot of interesting topics, and whatever topics I have studied, I am slowly creating videos on that. One thing that I can say for sure is this is one of the most beautiful languages in the world. It is so mathematical and like it is so pure that it just makes sense. Like it just clicks. Today's topic. Previously, we have covered R and its introduction, and we have also created a video for installation. We also kind of introduced objects that are there in R. Today, we'll be talking further in detail regarding the data structures that are there present in R. So let's get started. So R's data structure can be organized by dimensionality, which is 1D, 2D, or ND, and their content type, whether it is homogeneous, which is basically the same type of elements that can be contained, or heterogeneous, which is where like it can allow multiple elements to be stored together. There are five main data structures in R, which is 1D and homogeneous. There are atomic vectors, 2D and homogeneous, which is matrices, ND and homogeneous, which is arrays, 1D and heterogeneous, which is lists, 2D and heterogeneous, which is data frames. There is nothing for 2D and homogeneous because it doesn't really like make sense. Sorry, ND and homogeneous. Sorry, oh my bad. There is nothing called ND and homogeneous because it wouldn't really make sense. There is nothing called ND and heterogeneous in R, which is kind of it wouldn't really make sense because why would you want to store a ND and heterogeneous? Anything more than more with more dimensionality can be completed by using nested lists or nested data frames and such. So we don't really need ND and heterogeneous. One thing for importance is that there are no scalars in R. Everything that is an object in R is a vector. Even an object of length one, like if you just store x is equal to 5, then that x will become a vector of length 1. Now let's jump into coding, back into coding, and then we'll come back to the slides once as and when needed. So this, as you might know by now, is a basic RStudio window. This is the coding like scripting pane which we have. This is the console where each and every thing that you type in the scripting pane, its output can be visualized in the console pane. So let's get started. There are four atomic common types of vectors that we will discuss in detail, which are lists, vectors, sorry, in double, integer, logical, and lists. Um, you can basically check the type of the objects by using type of. You can check the length by using length. You can also check the structure by using str function, the structure, which is a structure function. Um, Double is a this is a double. This is how you create a double variable. Now this is a so basically what I did is I ran a double, and then when I ran this as double var, this tells me that there is a list of three elements here which has 1.5, 2.5, and 3.5 in it. It could very well have been x is equal to 1.5. That is also a double, but that is a vector of length 1. So if I check length of x here, it will give me length of x as 1. If I give length of double var, if I check, if I run the length of double var, it will run it as 3. So everything that you see is a vector. Don't imagine it as a list or anything. Just imagine it as a new element in R called a vector. Um, So now if I run the type of double var, it will give me double. And if I run this structure, then it will basically show me that if these are numbers 1 2 3 1 3 of 1 to 3 indexes. Starting index is 1, ending index is 3. The elements are 1.5, 2.5, and 3.5 respectively. So that is how double var is stored. With the L suffix, you can basically get an integer rather than a double. Integer var is stored as 1L, 6L, and 10L respectively. Um, C is basically a function that is used to combine 1L, 6L, and 10L together. It's basically used to create the vector. So now integer var, if I create it, and if I want to visualize it, the L's are dropped. If you see, the L's are dropped, the variables are stored as 1, 6, and 10. The values are stored as, sorry, the values are stored as 1, 6, and 10. And if I want to check the type of integer var, now it is stored as an integer. I could have what I would have if I would have basically done this as um, double var 1, because I don't want to create rewrite my overwrite my previous value. So if I would have done this, you would have imagined that because it is being stored as 1, 6, and 10, it would get, this would be the same value. However, this is wrong, because if I see here, what it would basically do, see, it will store it will store it as 1, 6, and 10 again. So integer var and double var have the same value. However, if you want to see the type of double var 1, then it will store it as a double. It will not store it as an integer. And type of integer var is integer. So that is the basic difference. The basic difference doesn't come in the number itself. The basic difference comes when you want to see the precision, because double has a much lesser of a precision than integer has. Integer is stored in 64-bit format, while double is stored in a 8-bit format. So that is the difference in between double and integer in R. You don't really need to worry about that as long as your scripting both are okay to use. I would even suggest you to use double, because double is easier on the machine, and it also stores it as a number it's only, which can be basically used as a double. So you can basically ignore the else and just write it as 1, 6, and 10. So that is very easy to use and is readable as well. There is one thing that I should call out though. For example, if I want to store it as C of 1.5, 2.5, and 3.5, the values that we had for double var. If I use it as this, what I would basically be doing, if I now make this as an integer, because if I don't use this as an use else here, if I want to use make it as an integer, what I can basically do is um, x is equal to uh, as dot integer var1. Now if I call this, what do you imagine will happen? You Sorry, I hadn't called it. So what do you imagine will happen? Now see, if I call this, then point 0.5, point 0.5, point 0.5 are dropped everywhere, and it just stores it as 1, 2, 3. Because integer is like the whole number, right? It's not integer value doesn't contain a precision. So that's why it's much easy. If you just store it as a double, that is much easier to use, because it also double also allows you to store a decimal point, which is basically a floating point decimal. If you consider Python, for example, like it has a float value. That float is exactly the same here as double. And you could have also x is, you could have also written as double. Now, if I call it as an double, though I don't really need to, because it is storing as a double right now. Because if you see the type of integer var1, it is storing it as a double. However, if you want to call it as double, then you can do that. and I can still call it as 1.5, 2.5, 3.5. So you can basically convert a variable into double as well, um, and it will just store the values. Now, the next thing is logical vectors. Logical vectors are basically true and false. It is basically logical var is equal to c of true, false, true, false. Now, if I want to run this first, um, the type of the logical variables created here would be logical. You can see here, which you can see here. The length of the logical variable will be 4, and the structure will be logi one, like 4 elements. Starting element is 1. There are 4 elements, so end index is 4. Their values are true, false, true, false. What I can uh, and finally the point is, there is atomic vectors are always flat even if you nest them. We'll come to the nesting in lists, but atomic vectors, if you create a list of atomic vectors, for example, I've created a uh, atomic vector here which has doubles in it. If I run this, it should basically have given me 5 6 by itself, and then 4, and then bracket of 5 6, and then 3 4, sorry, 3 4, and then bracket of 5 6, and then 2 bracket of 3 4 bracket of 5 6, 1 bracket of 2 bracket of 3 4 bracket of 5 6. But no, that is not what will happen, because what will happen is, if I run this, it will only give me 1 2 3 4 5 6. So it will basically flatten them out. And I can basically call it as length of D will always be a six elements list, 6 elements vector. Sorry, I shouldn't call it as list again and again, because list is what we used in Python. I'm getting confused over there. 6 element vector is how it will be. Finally, the important topic here is coercion. All elements of an atomic vector must be of the same type. So when you attempt to combine different types, they will be coerced to the most flexible type. Order of the types of most flexible are: the topmost is logical, the least is integer, next is double, and least is character. Like everything can essentially be boiled down to character, but character cannot be boiled down to anything. So for example, like string, if I want to see the structure of C, A and 1, then what will happen is 1 will get stored as in its character. It will not have a value. So if I want to see as numeric, if I want to convert logical var to numeric, what will it basically do is, it will, for trues it will give 1, and for false it will give 0. So it will give me a vector of 1 0 1 0, and basically what I can do is sum of logical var, which is true, and mean of logical var, which is 0.5, because 2 divided by 4, so 0.5. So this will come in real handy when we do like a case when type of scenario, but in R, not in SQL. So we'll create videos of that as well, and we'll show it out at how effective um, this coercion thing becomes at that time. So as I said, vectors basic data structure in R is a So as I said, vectors, basic data structure in R is a vector. There are 5 types of vectors: atomic vectors, lists, factors, matrices, data frames. Lists are different from atomic vectors because their element can be of any type. They're sometimes also called recursive vectors because they can contain other lists. We'll come to this in a subsequent video, subsequent uh, like next topic. We'll cover it in this video. Lists sometimes, like they different from atomic vectors, like because their elements can be of any type. So basically what these are is they're heterogeneous, 1D 2D or ND. It doesn't really matter how many dimensions there are, because lists can store lists within itself. Because so they're sometimes also called recursive vectors because they can also contain other lists. We'll cover this in when we go back to the R Studio window. Vectors have basically three basic elements. One is length. It is a description of how many elements there are in the vector. Two, type of the vector. And three, finally, attribute, which is the metadata of the vector. Factors. There are vectors that contain predefined values. This is class and level. We'll come to it when we go back to the R window. And finally, attributes of objects. Attributes of objects contain metadatas. They can be thought of as a named list. There are three attributes that are most important: names, dimension, and class. We'll don't worry about this just yet. We'll cover it in when we code it out. So lists are basically we can create a list by using list function. So if you imagine x is equal to list function of 1 is to 3 and AC and a vector of which contains true, false, and true, and a vector which contains 2.3, 1.3, and 1. This basically will create a list. I can visualize it by using x, by running x, and so the first element of x contains 1, 2, and 3. The second element contains AC. The third element contains true, false, and true, and the fourth element contains 2.3, 1.3, and 1.0. And if I want to see the structure of x, then there's it's a list of four. Everything is a character stored as a format of elements of list. So everything is represented by a dollar because it's a list element. First element is an integer, second is a character, third is a logical, fourth is a numeric. Between 1.3 with 1 to 3 elements, 2.3, 1.3, and 1. And we what we can do here, they're sometimes also called, as we had covered, it's sometimes called a recursive vector because a list can contain other lists. So now what I can do is I can create a list of list y, which is a list of 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 x, the list that we had created above. And so when I create this, what I will basically be having is the first element, which has two elements inside, which has three elements inside, which has four elements inside, which has fifth element, which is 1, 2, and 3. The fifth element ka second is AC, fifth element second is third, and fifth element's fourth is all these. So if you see, that is the structure of that is the representation of y. If I want to see the structure, then it's a list of one, list of one, list of one, list of one, and list of four, which are all of these four elements. And if I want to see is it a recursive list, then it's true. Is not recursive is a function that is used to check if the list is recursive or not. What we can basically do is this c function is there, that it will combine several lists into one. D, if I had a d which I was trying to create as a list of 1 and 2, and c of 3 of c of a vector of 3 or 4, and if I had a c e which is a list of 1 and 2 and c of 3 by 4, if I run this, what it will basically do is it will give me a list of two elements. The first list of two elements, which is a recursive list. So it has again a list, which has two elements inside, 1, 1, and 1, 2. The first element of that is 1, and the second element is 2. And then there is another element outside of that list, like in the main list, which has which is a vector and has two elements inside, 3 and 4. So 3 and 4 are stored together. If I run e now, um, it will simply run 1, 2, 3, and 4. So uh, that is what will happen. It will basically flatten it out, as in the form of a list. This uh, this will store everything together. So now, if I want to see the structure of D, it is basically a list of two, which is a list of two elements, uh, and outside it has again two elements. But the structure of E is it has list of four. So if you see, this is basically same as like that flattening thing that we were doing. Vectors are always flat. It's the same thing that we are doing here, because this is creating a vector it is creating an atomic vector. So that is why it is basically flattening it out. This is why this happens, if it makes sense. Now finally we can next is we can coerce objects into list object by using the as list function. So now if I want to if we'll cover empty cars in very high detail in next topics, because it is a data frame that is used very frequently for any format of like ggplot file running, or like anything like empty cars is one of the most used data set along with along data sets in R along with iris and others. But Z, if I want to create empty cars, if I want to create a data frame into a list, then what I can basically do is I can run this as this function, and I can check is list is Z a list? Yes, it is true, and I can visualize it as this. So the first element, second element, third element, and so on are all stored now in form of lists. Now attributes can also be thought of as named lists. They basically what they basically do is it this stores metadata about the object y is equal to 1 to 10, and attribute of y is basically my name, and it stores a value of this is my name. If I run this, then basically what it does is I can run this and see the structure of attribute of y and my name is it is a character and it stores this is my name. So basically, if I would have run attributes of y by itself, it has one element. It is creating a list which has one element inside my name, and it stores this is my name. So it's basically storing metadata about the object. What we can basically do is like there are a lot of attributes that can be stored inside a list, which we'll cover in the next topics. But there are three main things, which are names, dimensions, and class. Um so for example, if I want to store x is equal to c of a is equal to 1, 2, and 3, so it's a vector, but only the first element has a equal to inside it. So if I run the attribute function of names of x, see there the first element will get a name of a, and the second element and the third element will not get a name, so it will be blank. It will be null. If I would have run though it doesn't really make a sense right now, it really says null because there is no dimension of it right now. We haven't specified a dim. We'll cover it in when we cover matrices and arrays and data frames. Dim becomes a very important at that time. Um, and finally, if I want to see the class of x, then class of x is numeric because it is basically essentially storing three numbers inside it. Even though if I would have seen the type of x right now, it would have stored me as it would have stored a double. Now this is where I was talking about. The double is basically how the data is stored, and it's not really how what the numbers are. Class is represents what the value actually is. So it's a number. Uh, we'll next come to factors. Now, factor is basically a vector that can only contain predefined values and is used to store categorical data. It becomes really important when we are doing data frames and we are doing any kind of logical regression and those kind of things. This becomes really important because it is a way to store categorical information. Now, imagine if A is a vector which had A, B, 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 A inside it. I want to convert it as a factor, so I will write factor function and I will write C. And now it will basically have A, B, B, A. It is telling you that it has two levels inside A and B. Now it doesn't really make sense here. So basically, what I can basically do is I can create a gender list. Gender char is equal to C M M M M, and right now if you see uh, if I wanted to see a gender of character, what it will basically have given me there are four m's inside. But if I want to run this factor and levels is equal to C, M, and F. If I run this, sorry, if I run this, and then if I run the table function, it will give me there are two levels inside M and F. There are four M's and zero F's. So that is why factor is important, because of this levels function. It basically tells you what levels there are, and it would become really important. For example, if you visualize the Titanic data set, then there are various classes inside, P class, S class, and so on. That time this become the passenger classes. That time this factor becomes really important, because it tells you there are three levels of passengers and so on, or something. So that is the where this factors function becomes really important, and especially the levels becomes really important at that time. We'll next move to matrices and arrays. The matrices and arrays are basically two Taylor's arguments are specified, uh, are used to specify rows and columns. A is a matrix of 1 to 6. N call is an important value here to specify, and n row is important as well. What n row specifies is how many rows there are, and n call specifies how many columns there are. What I can basically do is I can run this. It will basically give me an object which has three columns inside, two rows inside. It will basically store data in so matrices are basically used to store data in a tabular format, and it usually fills data in column wise. So if you see 1 2 follows, and then 3 4 follows, and then 5 6 follows. I can also create an array of 1 to 12. I can basically create as an nd 232, where this is used to specify rows, this is used to specify columns, and then this is used to specify how many slices there are. So if I want to see b is equal to array of 1 to 12, now how if I visualize b, see right now it is telling you I'm in the first slice of data, because if you visualize it as a cube, it is basically telling you that it is by the first height. If you visualize it as first height has first slice has three columns inside and two rows inside, which is this, and the second slice has again three rows inside, three columns inside and two rows inside, which is this 7 through 12. So that is why this becomes important. This is used to represent slices. You will understand this when we come to data frames. Matrices usually fill values by column, but what we can do is basically we can specify the by row equal to true, and it will start filling by row. C is equal to matrix of 1 to 6, n row is equal to 2. What it will basically do is that it will create me a it will create for me a matrix of 1 to 6, but it will fill by 1 2 3 4 and then 5 6. But if I would have specified by row equal to true function, by row equal to true value, now here this would have given me 1 2 3 and finally 4 5 6. What I could have also done, I believe, let me just check it out. Oh no, that is a different thing. One surprising thing here comes when you check the class of a matrix versus its type. If you check the C's type above, it's an integer. However, its class is matrix followed by array. This happened because of a magical R property, which is called S3 class inheritance. Now, if I want to check the type of C, it is basically an integer because it has 1, 2, 3, and 4, 5, 6. But if I want to check the class of C, then it is a matrix followed by an array. Why this is giving a matrix and an array is a really interesting aspect, because in R there is something called as class inheritance. Any function that is that doesn't support matrices inside it, there are such functions that only support arrays, then for those this value becomes an array. And otherwise it is, if a function supports matrices inside it, then it's a matrix. So it is a matrix. If it doesn't have that matrix value, then it is a class, in class inheritance of array. So it has a matrix and an array. So that is why S3 class inheritance comes in. S3 class inheritance is something that it is not covered in this video. We might cover it in future segments. We can also modify an object in place by setting dim c is equal to 1 through 6, and dim of c is equal to c of 2, vector of 2 and 3. So now if I specify c is equal to 1 to 6 and so if I now want to say c, then it will have three columns inside it and two rows. So basically 2 becomes the rows and 3 becomes the columns. And length of c will be 6, n row of c will be 2, n col will be 3, and dim is 2 and 3 because 2 rows and 3 columns. If I, what I can basically do is I can specify the row names of a by using a and b functions. Row names of a will have a and b, and call names of a will have a, b, and c. And so if I want to visualize a, then it will have 1, 2, 3, 4, and 5, 6 as was stored above, but it will now have names inside. A, B, and C in capitals are the column names, and A, B in capitals are the row names. What I can also do is I can store it as a list. Dim names B is equal to list C of 1, 2, C, A, B, C, and C, A, B. And so if I want to specify B here, then the first slice has the name of A, which has these elements inside, and the second slice is B, which has these elements inside. So that is why it becomes important. You can also transpose a matrix by using array. This is what I was trying earlier, but I realized that transpose is different by as compared to like changing the names. Transpose is basically if I want to transform a 2 by 3 array into 3 by 2 array. And so basically what I will basically have now is a, b, and there are now three rows. 1, 2, 3, 4, and 5, 6 are the different rows, which were earlier the columns. However, for transposing a array, it it doesn't use function of t. It uses a function of a perm, and a perm of b is slice of 1 has a, b, and c inside, and slice of 2 has all of these inside. Earlier it had slice of a and b, and 1 and 2 were rows. Now 1 and 2 have become the slices, and a and b, which were earlier the slices, have become the rows. So so if you see this, this is how this becomes important. Um, we can check the is matrix function. Is it true? Yes. Is it true? Is array? It's true. So we can also convert into an array as array. It gives you the entire array 1, 2, 3, 4, 5, 6, and uh, the one thing that was confusing me at that time, if you see, if I see b by itself, see 2 has three elements here, 2, 4, and 6, and three elements here, 8, 10, and 12. And when I transposed it, 2, the second slice of 2 becomes 2, 4, and 6 together, and 8, 10, and 12 together. That is a fascinating thing. And similarly, 1 had 1, 3, and 5, and 7, 9, and 11. And so 1 becomes 1, 3, 5, and 7, 9, 11. So that is what a perm function, if a perm of b function does. It basically transposes an array into this format, which is kind of very interesting to see. We can basically come. We'll pause it for now. We have to cover data frames as well. However, this video, it'll become too much for this video. You can come back for the data frames in the next topic, and we'll cover it at that time. Thank you for seeing this content. If you are liking this content, I will have more videos created for our SQL, um, fraud fighting, A/B testing, and everything. I will create videos for everything, and playlists for everything. You can hit like button, subscribe button, if you want to hit like and subscribe the videos, if you like this content. And if you want to add anything, or want any changes to be made, then you can advise on that as well, by using the comments option. So thank you for that.